In this video, we'll look at some addition and subtraction of fractions. Remember, the first thing that we're going to do in each of these questions is find the lowest common denominator between the two denominators, assuming that they're not the same already. So let's start with this one, 3 over 4 plus 5 over 6. So we need to find the LCD between 4 and 6. So let's look at the multiples of 4. So multiples of 4 look like 4, 8, 12, 16, etc. We can always go further if we need to. Then for 6, we get 6, 12. Well, you already have a common term here. So we're going to use 12 for this question. So that means this first fraction needs to get multiplied by 3, top and bottom, to get to the 12. And the second fraction gets multiplied by a 2, top and bottom. So that brings us to a 9 up top over 12 plus a 10, 5 times 2, over 12. So now adding these together, 9 plus 10 gives us 19 over 12. So this 19 is a prime number, so that's not going to be reduced anymore. And now I'm dealing with either a improper fraction or I can do a mixed number. So this answer is fine for a lot of cases, but if you wanted to make the mixed number here, we'd have to ask ourselves how many times does 12 go into 19? Well, that goes in once, and it leaves 7, because 19 minus 12 is 7. So we put a 7 up top over 12. So this is your other acceptable answer. Now let's take a look at example number 2, 7 over 10 plus 5 over 12. As your numbers get bigger, you may find it a little bit tedious to start counting out 10, 20, 30, 40, 50, and 12, 24, 36, and so on. So there's another way that you can use that prime factorization to get the LCD in this case too. So let's start by doing that. So I'm going to do a prime factorization of 10. So let's take out a 5 first, and then, well, that leaves us with a 2. So the prime factorization is just 5 times 2. Now let's do 12. We can take out a 2 first. That's going to leave us with a 6. Keep that 2. And then the 6, take out a 2, and that leaves us with a 3. So now we've got 5 times 2 for 10 and 2 times 2 times 3 for 12. So the LCD is going to be equal to all of the unique parts here. So let's just write this as 5 times 2, and we'll write this as 2 squared times 3. This is just another way to do it in case you don't want to count out your multiples. This takes a little bit of getting used to, but it is more flexible once you get into larger numbers. So we're going to take one of each of these different numbers. So there's a 5 and the power is 1. There's no 5 here. So we're going to need 1 5. There's a 2 and then there's a 2 squared here. Between the two, we have to take whichever was larger. So we're going to take the 2 squared. And then last, there's a 3 and then no 3 here, so we just take a 3. So now if I multiply this out, 5 times a 4, 2 squared is a 4, that's 20. 20 times 3 is 60. So that is our LCD. You would find the same thing if you were to get out multiples in the same way. So let's go with 60. So that means this one needs to be multiplied by 6, top and bottom, to get to 60. And the second fraction, 12 times 5, is what gets you to 60. So now 7 times 6 is a 42 over 60, plus 5 times 5 is 25, and then 12 times 5 is 60 again. So now adding together here, we're going to get 67 is 42 plus 25 over 60. And 67 again is another prime number. So if we left it as an improper fraction, this would be our answer. If you did want to go to a mixed number, same sort of question. So 60 is only going to go into 67 once, and there's a remainder only of 7. So 1 and 7 over 60 would be your other answer. So we'll finish by doing a couple of subtraction examples. So now here we got 12 and 18. So these numbers are getting larger. I'm going to do the prime factorization method again. So as we get faster, prime factorizations don't take as much time. So I'm going to do this one a little more quickly, and if you need to pause the video as I'm doing it, you can do that. But I just want to show you in real time about how fast this can be done. So 12, if we take out a 2, that leaves us with a 6. and then we get a 2 and a 3. I'm not going to draw my squares here. And then 18, pull out a 2, that leaves a 9, and then you take out a 3, and we get a 3. So we get 2 squared times 3 is the prime factorization for 12, and 2 times 3 squared is the prime factorization for 18. So our LCD is going to use a 2 and a 3, and let's figure out the powers. So the first one was 2 squared, and the next one was 2, just to the power 1, so we take the higher of the 2, and then 3 and 3 squared, so we take the higher of the 2 there. So our LCD is 4 times 9, which is 36 here. So if you were to count up multiples, you would have found the same 36. So that means we're multiplying this by 3 and this by 2. So now we've got 5 times 3 is 15 over 36, minus 5 times 2 is 10 over 36. The subtraction here is pretty simple. 15 minus 10 is 5 over 36. 5 is a prime number, and it's not going to divide into 36, so that is reduced. This is a proper fraction, so no mixed number can be given for this one. Okay, for this last subtraction example, so we need to find a lowest common denominator between 9 and 15. So I'll go ahead and list out the multiples. We'll get 9, 18, 27, 36, 45, 54, and so on. For 15, we get 15, 30, 45, and I'll stop there because I have a match. So we want to go to 45. So that means we're multiplying this one by 3 and this one by 3. And 9 gets multiplied by 5, and then so does the 8. So now working this out, 8 times 5 is 40, over 9 times 5 is 45, minus 5 times 3 is 15, over 15 times 3 is 45. Subtracting now, 40 minus 15 leaves us with 25 over 45. And we can definitely reduce here. We can divide top and bottom by 5. So 5 divided by 5 gives us 5. So let's just write out the division by 5. And 45 divided by 5 gives us 9 again. So we have another proper fraction, and this is now reduced. 5 is prime and doesn't divide 9. So we're done.